Kinematics question 3. We're told a particle P is moving in a plane. At time t, P is moving with a velocity v, where v equals 2ti minus 3t squared j. Just recall our little map, which shows if we take displacement, differentiate, recall our picture, which shows displacement, differentiated with respect to time gives velocity, differentiated a second time gives us acceleration. We integrate to go in the reverse direction, and on the right hand side we have the dot notation, r dot being dr by dt, r double dot being the second derivative of r with respect to t. So here we're given the velocity. I'm going to write it in the r dot format. So it's r dot equals 2ti minus 3t squared j. We're asked to find the speed when t equals 4. This is a simple case of substitution. When t equals 4, 2t is 8, minus 3t squared is minus 48. So we want the magnitude of 8i minus 48j, speed being the magnitude of the velocity. A nice trick is that you can factorize these vectors. So it's actually 8 times the modulus of I minus 6j, which equals 8 square root of 37. We're then asked to find the acceleration when t is 4. So first of all, we need to differentiate r dot to get r double dot, the acceleration. And here we're going to get 2i minus 6tj. We simply differentiate component-wise. And then when t equals 4, we'll substitute the value of 4. And here we get the acceleration, or r double dot, equal to 2 minus, we substitute 4 into 6t to get minus 24j. Then we're told P is at a point with position vector minus 4i plus j when t equals 1. We've got to find the position vector of P when t equals 4. So let's write the r dot expression again. To go from velocity to displacement, to go from r dot to r, we integrate. We integrate this, we integrate 2t to get t squared, minus 3t squared to get minus t cubed, and we have a constant of integration c, which itself is a vector. We substitute t equals 1 in here, and we're going to get a result minus 4i plus j. So minus 4i plus j will equal I minus j plus c. So we can calculate the constant of integration as being the vector minus 5i. So we can calculate the constant of integration as being minus 5i. So we can calculate the constant of integration as being minus 5i plus 2j. And substitute it back into the original expression and group the I and j components together. So we get the displacement, t squared minus 5i plus minus t cubed plus 3j. So to find the position vector of P when t equals 4, we simply substitute t into 4, and we get r equals 11i minus 62j.